Everyone, thank you so much for joining us. My name is Paul and I'm with Danish Pro Audio, or DPA microphones, along with Chris and Kate, and we are going to chat with you this afternoon about miking Broadway and theater productions and the various aspects there within on mic placement, hiding them. So without any further ado, let's jump in. Really quickly, I want to give you a background about who is DPA and where do we come from. Well, we are a Danish company, as I mentioned before, Danish Pro Audio. We manufacture all of our products in Denmark. We are a handmade company, and we build a variety of solutions across the board, from everything, as I mentioned before, Broadway and theatrical productions, all the way to live sound and recording studios. We have a long developed relationship with a company called B&K. Has anybody heard of Brule and Carr? A few of you out there? Fantastic. Yes, there's three of us. Yes, good. That's great. So they are primarily a testing and measurement microphone company, and the reason I want to bring that up is because there's importance within the way, the mindset or the philosophy that they have within this, and that is that they need to create a microphone or a testing instrument that is going to be completely linear or flat. So when you think about that in highly critical applications, if you have a microphone that has a tendency to exhibit its own characteristics, or it is pre-EQ'd in a way, it's going to have a character, and it's going to embark that character on whatever the sound source is. So when you think about that in scientific applications, testing and measurements, at the end of the day, that test is going to potentially be skewed if that microphone isn't as flat and accurate as it possibly can be. So with all that being said, DPA has taken that same philosophy from B&K, and we've introduced it into all of the solutions or all the microphones that we build today. So what we are offering you, and it doesn't matter whether it is a headset like this one, or a lavalier, or a pencil condenser, the frequency response is going to be as linear or as flat, so that we are capturing the source as accurately as we can to represent that to you, so then you have the opportunity to then manipulate it if you so choose. But we want to make sure that we are giving you the most accurate representation that we possibly can. So, moving forward, topics of discussion today: maintaining intelligibility, off-axis frequency response of microphones, and we'll have some real-world limitations and solutions that Kate is going to fill us in on. It's going to be fantastic. I'm super excited about that. So are we ready to jump in? Let's do it. Okay. Facts about intelligibility. Human voice. What determines intelligibility? Well, there are several things that we need to pay attention to: the level, the dynamic range, the pitch, the frequency range, the noise floor, and reverb. We have a really difficult time with intelligibility at the moment.
Wow, you planned that.
We did, yes. Yeah. Thank you guys over there. Okay, so let's start off with the level. If we take a look at the average human voice, we see the RMS, or the program material that's taking place there. But then we also see what's called the crest factor. Now, the crest factor, we see here that you have a potential of 20 to 23 dB above the RMS. So you've got some serious peaks that are potentially taking place within the voice and the dynamic range within that. So it makes it really important that as professionals in whatever the industry we happen to be in audio-wise, that we are able to capture that, not only the RMS aspects of it, but all of this, the surprising peaks that we may not anticipate, because of the fact that people are so emotional, right? And they get excited about things, and so the
and
dynamic
placement
range
has an effect on that too, because if you're putting a microphone here in somebody's ear, because for example, if they don't have enough hair, so you're trying to bury it here, you'll get more of the resonance of their jaw and less of the sibilance that you normally get. So we account for that too when we place the mics.
That's fantastic. Yes. If we take a look at the dynamic range of hearing. Okay, so on the left side, we see the yellow highlighted section as being the primary frequencies and overall volume level that we are concerned with in regards to speech itself. Notice how when I highlight this section here, now I am focusing in on the specific frequencies of intelligibility. But what we're also looking at is the overall level. So as we get excited and we start to raise our voice and yell, the intelligibility doesn't necessarily increase with that. You can see that there is a limit that in this picture it's showing about 85 decibels, right? So even if I am shouting at someone, that doesn't make me to be able to be understood anymore, if that makes sense. The other thing we want to pay attention to is as we move over to the right side of the graph, now we are looking at someone who has experienced a certain level of hearing loss. Maybe they've attended too many Metallica concerts, or they've been to too many AES conventions on that side, right? Who knows what that happens to be. But now you see in this particular instance where we're not working with as much material or as much capability in order to understand what's being said. So the intelligibility in somebody who is older or has experienced the hearing loss, it's that much more important that we can reproduce that sound as accurately as we possibly can, so that even those folks who are sitting out in the audience can understand what's being said up on stage. True?
Yeah, absolutely. Go ahead.
Cool. Okay, I have a slide here that I'm going to play back, and hopefully you guys will be able to hear it well enough. What I'm going to be doing is I'm going to be filtering in and out various frequencies so that we can start to narrow in and determine what are those specific frequencies that really determine the intelligible range of the human voice, okay? So let's see if we can, if we'll hear this. It's going to start off on the top. It's going to be an English gentleman, and he's just going to be reading from something. But you'll notice that as I filter through it, it should become less and less intelligible.
In language, infinitely many words can be written with a small set of letters. In arithmetic, infinitely many numbers can be composed from just a few digits with the help of the symbol 0, the principle of position, and the concept of base. Pure systems with base 5 and 6 are said to be very rare.
But base 20 occurs in English when we use score, as in 4 score and 7. Eventually, most systems would keep pace with the decimal or arithmetic system, which has 10 numerals. The digits 0, 1, 2, 3, 4.
5, 6, 7, 8, 9, and a decimal point. The numerals take different place values depending on position. So the number 819.65 can be shown as 8 times 10 to the 2 plus 1 times 10 to the 1 plus 9 times 10 to the 0 plus 6 times 10 to the minus 1 plus 5 times 10 to the minus 2. Monetary systems have evolved to make use of this base 10 notation. France became the first decimal country in Europe in 1788, Belgium, Italy, and Switzerland in 1865. Germany's decision for 8 years later, the same
So hopefully you were able to distinguish the differences there and listen to, as I was filtering in and out the various frequencies. What did you pick up on? What were the key frequencies that kept the intelligibility? Anyone? Yes. That's excellent. Yeah, so he's got 2 and 4 there. Yeah, those are right in that primary range. Fantastic. Looking at the intelligibility side in regards to the noise floor. So, if the noise level is 10 dB louder than the speech level, then that speech is only going to be 60% intelligible. So as we are sitting here today, we have quite the noise floor that we're dealing with all around us, right? So in order for me to remain intelligible, we want to make sure that I'm at least 15 dB above that to be in a comfortable, intelligible range, if that makes any sense. Let me ask you a question. So when you have several things going on stage, an action scene or something, right? And there's potentially a lot of background noise or something that's taking place. How do you compensate for that?
We usually leave it up to the mix engineer to
Yeah.
deal with a lot of that. So, yeah, exactly. That's sort of why Broadway engineers are sort of
Do what they
specialized at
Yes.
their jobs. So yeah, if there's a fight sequence or even just dealing with monitoring, right? Because any musician is going to need to, any singer is going to need to hear themselves, is going to need to hear the band.
Right.
So it's very common to have foldback on stage for them to hear just a little bit. So what we tend to do from my experience is we'll sort of trim the low end down a little bit and then keep those 2 and 4 and 6 frequency, 2, 4, and 6K
Okay.
a little bit hotter so that we can sort of, in an EQ way, filter out the other stuff.
Absolutely. That's great.
And I'm going to ask you a question also. I mean, now with all the lot more contemporary type of musicals happening with rock bands on stage, and as opposed to the traditional pit, I mean, the stage volume's going up even louder, right? So it's even more to have to deal with.
Definitely.
So the fullback plus the rock band right behind them.
Definitely.
Yeah, absolutely.
Yeah.
So, mic placement in a situation like that.
Mic placement is challenging.
Yes.
And every designer seems to have their own method of how to deal with it. Some designers are holding very steadfast to the center forehead position.
Okay.
Some designers are doing the boom situation. I think that Waitress is one of the shows that I work on, and I know that Jonathan Dean's the sound designer for that. Had a conversation with Sarah Bareilles and the directing team about mic placement and wanting the boom specifically so that it could sound as close to a rock concert as possible.
Oh, nice.
Because they wanted that low end response that you're not really able to get when you put a microphone in the center forehead position.
Right.
So yeah, that's kind of, I guess, one of the things that's I've witnessed changing a little bit more is more and more musicals going to the boom situation.
More headboard stuff.
Yeah.
Okay. Very good. So let's talk about how do humans project? If we take a look at this bird's eye view, this diagram, the overhead, whether it be the A-weighted or the octave bands, we can see the projection is primarily in front in terms of the higher frequencies. The higher frequencies being the ones that we need to pay attention to in regards to the intelligibility. The resonance and the lower frequencies we see does come from behind, but this is why it makes it so important, say when you're having a conversation with someone, that you don't turn away because those higher frequencies are going to follow that head movement. So it makes it much easier for the communication to take place back and forth when you're focused on looking at the person you're actually talking to. Here from the side view, we can see that it projects forward and up. So you had mentioned the forehead position, right?
Yeah.
You can see by this diagram why this is a key position, why it's probably one of the favorites, yes?
Definitely, yep.
Just because of the simple fact that it is all frequencies are being represented up in this range. We did some really fun experiments in and around mic positions, and I want to show you the results within that. What we ultimately ended up doing is we took 4 different microphones that are exactly the same, and we ended up placing them on different areas of 10 different test subjects or different people, so that we wanted to gain an average out of those 10 people and really start to learn about, okay, where is the best place to put a microphone in terms of intelligibility. We started off with a reference, and we were about 1 meter away, so this is that common distance for conversation, right? So this is our reference. This is where we decided, okay, this is where it's going to be the most flat. We then moved on and we put that microphone on the forehead. You can see there that, yes, the frequency response has been manipulated to an extent, but it still has a lot of the same characteristics as the reference or the flat. As we move to the ear position, now we start to see some dramatic changes, especially in the high end. If we move to the cheek position, it's different yet again. Finally, when we move to the lapel position, now we're seeing the most dramatic differences compared to our reference. If we want to take a look at all 4 of those together, I'm going to highlight a few things in this chart as I basically smooth these out a little bit. You're going to see that there's an 800 hertz bump in each one of these. Does anybody know why that may be?
I have thoughts, but
No? Okay, go for it. Go for it.
Is it the resonance?
Very good, yes. So this is something that potentially needs to be compensated for no matter what the position happens to be. Notice the steep drop off right when you move it to the ear position. When you move to the cheek, now you've got this shelf that takes place. And finally, when we move to the chest position, there's that 800 hertz bump, but then we have a serious dip that's taking place right there, and that is right in the intelligibility range. Those are those frequencies that we need the most. So the most compensation is going to have to take place when we're placing these microphones down in this area. If we look at the level differences between the various positions, you can see that the cheek is definitely the highest, simply because it is closest to the source, right? As we continue to move in the lapel position further and further away or down the chest, we can see that those levels are also dropping accordingly. So, some conclusions from the experiment. Moving the microphone from the chest to the cheek provides as much as a 10 dB increase in the signal, which is great. Microphones placed on the chest, they must be equalized or compensated for because of the loss of intelligibility. Do you put microphones in this area very often?
Not really, not
No?
for live applications.
Right.
Occasionally, like a corporate event, if somebody's just up at a podium talking, sometimes they would prefer that.
Yes.
But for Broadway or any sort of live performance situation, it's really not ideal, because you're also dealing with, this is a moving object and this is a moving object, right? So if you put a microphone here, then as soon as I do this, you're losing it.
Right.
So we kind of want to lock everything in as tightly as we can to the performer's face, so that it moves with them, right?
Very little costume mounting, if there's costumes involved, very little kind of chest-worn costume mounting, correct? I mean,
Yeah,
not necessarily
almost none.
done.
Yeah.
Whereas in TV and film, they'll do that a lot. They'll stick it in the costumes.
Right.
But on Broadway, you're not.
And then they
doing
fix it in post.
Exactly.
Exactly.
Yeah.
You don't quite have that opportunity,
No.
do you?
No.
Okay. All right. Let's move on to off-axis. Everybody understands what off-axis is, right? Bob is on axis with the microphone, Alex and Chuck, they are off axis. Well, I'm going to guess that pretty much everything you do in regards to mic placement on an actor is off axis to the source, true?
Yes.
It's not going to be very often that you have this opportunity.
Not really,
right?
no.
So, off-axis frequency response, and why is this important? If we take a look at a frequency response graph like this one here, we see the top line being the on-axis line. We see the subsequent lines below that as being off-axis, 30, 60, 90 degrees off. Now, the thing that's important to take note of here is that these lines are primarily parallel, going across each other, right? This is the characteristic of a microphone that isn't going to give you a predetermined EQ setting that boxes you in to a certain extent. So what is this spec telling you is that they're trying to capture the source as accurately as they possibly can, both on and off axis. So in a live situation where, say you and I are on stage and we're having a conversation, my microphone is going to be picking up your voice to an extent, right?
Absolutely.
So there's a secondary sound source that's taking place, but you're definitely or potentially more on axis than I am, right? Or if the microphone is placed here.
Sure.
So we want to make sure that her voice coming into my microphone is going to be just as accurate as my voice going into my microphone, right?
Yeah.
So give us an example of how many times and potentially open microphones would you have on stage at any given time that are going to be interacting with second, third, fourth,
16, 24. How big is the ensemble?
Yeah, exactly, right?
Yeah.
Right.
Yeah.
So you can understand in critical applications that Kate is working in, you can see how all of these microphones potentially on stage, if they are introducing character or if they are not accurate off axis, we can run into some serious problems. Here's an example of a competitor's microphone that is showing us the on and the off axis response. Now, what we're taking a look at here is several different things that we may want to consider. The first one is that the on-axis frequency response, which is the blue line, has been pre-EQ'd. It has definite dips and it has definite boosts at key frequencies, saying that this microphone is going to be good for a specific purpose. So this microphone may be fantastic for the human voice, but it may not be good for a guitar, or it may be great for a kick drum, but it's not going to be good for the human voice, right? So they're building this microphone for you for a specific reason. The second thing that we're looking at here is that as we go off axis with these lines, as we continue to go with the green and the red, now we're seeing that these lines are actually crossing each other, right? So there are various points where we're seeing this take place. Now this is where the inaccuracies of an off-axis response can really start to cause us problems. Here we are introducing potential phase issues, so you can have cancellation or potential omni issues. So at those specific frequencies, that microphone interacting or off-axis will potentially be omni at that state if it's a directional. So we want to make sure that we are maintaining the flat frequency response both on and off axis. I'll just jump back to this one so you can kind of compare the two. You can see how different each of those are and how in the end the accuracy is going to basically speed your jobs up, right? Not only on and off stage, honestly, in terms of not having to manipulate and work through these problems, because you've got actors that are moving in and out of each other's microphone fields, right? That would potentially be causing a lot of these issues if you have the off-axis response not accurate.
Sure.
True.
Sure.
So keep in mind, our big takeaway in terms of the off-axis linearity or lack thereof is that the output of any microphone is the sum of the input of all of its angles, right? So just keep that in mind as you guys are going about your work and paying attention to, yes, there are going to be secondary sound sources, and we need to capture those as accurately as we can. Before I hand this over to Kate, do we have any questions about what we've talked about so far? Yes. I think we have a microphone that we can pass around a little bit.
Yeah, hello. Yes, in your previous experiment when you were testing different positions for the microphones, the microphone is an omni or cardioid patterns?
In that particular experiment, they were all omni.
Okay, and if you're talking like an off-axis, you're talking about specifically for the cardioid pattern that you would see here, or also for the omni experiment that we did before?
So whether it be an omni or a directional microphone, clearly the directional microphone is going to exhibit potential off-axis variance to a greater degree. So whether you are using a directional or an omni, I think it's very important to be able to say, yes, whatever that sound source that you are not necessarily focused on, yet it still needs to be accurate.
So there still is off-axis to worry about if it's an omni.
Absolutely.
Yeah, and I think everybody has probably been to a show or done a show where there's multiple microphones on stage, two people dancing with each other or close to each other. All of a sudden there's some weird phasing issues. You can't EQ that out. It's impossible to EQ it out, and there's not much you can do about it. But knowing what mics you're using and knowing what these graphs look like, even before the show starts, allows you then to start thinking in your head, oh boy, the mic I'm using may not be this well behaved. I got to figure something out because I have a scene where it's a love scene and they're basically on top of each other and we're going to have big time issues. So as a sound designer, or even as an A2, having your input saying, hey, we should probably place the mic here versus there because there's going to be some bad interactions. Kind of having this data ahead of time and knowing what you're going to walk into can help out a lot, big time. Yeah.
There's a lot of tricks that sound designers do use also to accommodate for some of those phasing issues.
Right.
Adding 5 milliseconds of delay to one of the performers, putting people through an A/B sound system, and letting the phase cancellation happen in the air rather than happen in the microphones and in the system is another thing that folks seem to do. And then also just having a really good mix engineer.
Yeah, or even just like headset placement. Knowing I'm going to have it on my right side, but she's going to have it on her left side because most of our scenes are like this, and separating the mics just by our bodies basically.
Yep. Yep. It's big too.
Let's hand it over to you, shall we? Yes.
We have show and tell.
Yes, we do.
I have all of the things. We've talked a little bit about multiple different mic placements. One of them being the boom position, one of them being the center forehead position. A2s and people who are responsible for hiding microphones in a live application have a lot of different tricks to make them stay in place. Because ultimately, if I'm putting this too tight and then I tip my head back, then you can see that the microphone moves down here. And that's not so good for intelligibility. So anything that we can do on stage to help lock that in is really key for the designers and then also for the audience. We'll use any mounting point in somebody's face or head. Hair is great, ears are great. I can't think of anything else.
Prosthetics, if you have I know some of the shows have the fake chins and masks.
Beards
and
things, right?
Yeah, there's a show that I did, 12 years ago now that had a mask that went on and we were able to, it was like a witch's mask and we were able to mount the microphone right in the tip of the nose. So talk about the best microphone placement you could possibly get. There's a lot of different things that we can do. I brought a couple of rigs to show you guys. I don't know if this is helpful. So these are the 4065s that DPA made for a while. Are you still making them or not? Sort of. You're not really telling
Technically,
people that
sort
you're
of.
making them?
Technically,
okay.
sort of.
How's that for an answer?
Great. So these are great because unlike the Defiance or any sort of like flexible headset situation, if in a Broadway application we know that we're going to have 8 shows a week, probably with the same performer or the same set of performers, so we can make this so that it never moves from that person, right? So this one is designed to be mounted underneath a wig cap. So actors will come in, do a full set of pin curls, put this on, and then put the wig cap over it. And what that does is it uses all of their natural hair to just glue it right to their face. And then
Was this from Waitress?
this is from Waitress. Yeah, this is.
I think I even have a picture that.
Oh,
that,
cool.
I acquired somehow, maybe from the designer.
Who's that?
There we
I don't
go.
know who it is, but
Oh, it's Jesse. Hey.
Cool.
Yeah, so in Jesse's mic situation, we were finding that if we mounted it in the bottom pin curl, so normally they'll do their entire head, right? This is just a mock-up situation. We were finding for her in particular, her wig and her ponytail was a little bit heavy. So as the show progressed, the wig would kind of shift this way, which would then make the microphone go this way, right? So what we decided to do was mount it over the top of her head. And that way, as the wig shifted back a little bit, it seemed to stay in place a little bit better.
and her mic was just for her. Then once you got it,
Once it's
fit on
set,
her head,
it's set. Yeah,
no one
this
else
is
using it, right?
this is Allison's. Allison Luff was one of our later Jenna's. Jenna's the character. So this is her microphone. Jesse's is, I think, in a box somewhere at this point. Yeah. So yeah. Then the wig cap goes over that. The wig goes over that, and you can't really see any of the headgear stuff. What I do also is it's great that fashion has decided that neutral tones are going to be the new nail color. So if a performer is lighter or darker skin, obviously we don't want to have a beige microphone down the side of somebody's face if their skin color is significantly darker than that. So I'll take nail polish and paint the side of the microphone. And then there's this magical trick. Big Matte Top Coat is a matte nail polish. Most of the nail polishes are shiny, so then the light doesn't pick up on the shininess of the microphone, and it blends in a little bit better. So we don't want to make it obtrusive, right?
Right.
The idea is for it to be completely hidden.
right. So and painting all the way up to the capsule, even like the cable, the headset assembly, and all the capsule itself. as
Yep.
well.
And then I'll take for these, right? They have the cap on the end.
Yeah.
So I'll take her skin was pretty light, but I'll take the cap and actually just paint right around the ridge of the cap too. So we do some of that.
Do you ever use some of the, Paul just pulled up a picture, some of the liquid paint and stuff, I guess just another type of a tool besides nail polish, I guess.
Yeah.
I don't know what brand that is, but it's one of the
So-
liquid paint pens.
Yeah, those are great for, what's that?
Okay, there we go. What he said.
Yeah, those are great for the flexible cables, right? So the material for this harder wire and then these flexible cables are obviously different. Yeah, the liquid paint, some people use the shoe polish or Copic markers are another one. I think I brought some. But yeah, so to get the color to stay to the cable is going to be different than to get the color to stay to the microphone. Yeah, these are the markers that I use sometimes. Same sort of situation.
Yeah,
Okay.
and we've been
Yeah.
told leather paint works well, stuff for leather bags and leather shoes.
Yeah.
I have a can in my bag, spray paint. That
Yeah.
works well to stick on some of the cables. So it doesn't,
Yeah.
it just doesn't crack off. Once it dries, it's still flexible like a shoes or a purse should be.
Yeah.
It doesn't come off. So.
It does over time,
Yeah.
right? Because we're putting these microphones in Broadway through hell kind of every single week, right? 8 shows a week, performers are sweating, costumes are getting ripped on and off. So usually we'll have like either an every other week work call or an every week work call to kind of touch up that color.
Okay, so that's what I was going to ask you.
Right.
So a week or two at the most, then having to touch up everything. pretty
Yeah,
much.
yeah, and it depends. I mean, it's performer by performer, right? I was discovering that some of the performers who were using like oil in their hair, those were wearing the color off significantly faster. It seemed like it was actually reacting with the paint and then causing the paint to like scrape off.
Yeah.
So that was a whole nother set of experiments. And I ended up going with nail polish on the cable, even though it does kind of flake off, but simply because it wouldn't rub off and then get in their hair.
Yeah.
Because obviously nobody wants to deal with that, right? It's kind of gross. Yeah, and then we'll use tape too. So once you get everything kind of colored correctly, hair, right. Hair is toupee clips usually. So these kind of guys, they're like little tiny barrettes. So we'll put a little piece of elastic between the two points on it. And then for the lavs rather than the headsets, right, this will get looped through. And then that can clip right in somebody's hair. So that'll kind of stay put.
Same thing for beards as well. That's the same. Or you use something different for.
If they have a really solid beard, then I've used this. But performers don't really like things touching their face very much.
Yeah.
So anything that we can do, if they have a beard and the designer wants the microphone really close, then usually we'll try and either do sort of a custom ear rig with some wire and some fishing line or clear acrylic thread to like tie it to the wire, and then kind of build a custom ear rig that way so that you can see that.
We might have a shot of a custom ear rig actually right there.
Yeah.
Hard to see, but it's a lot basically stuck on a metal wire with that fishing wire wrapped around it.
Yep.
Now,
Just to kind of
is
make
it
your own
true?
custom
Do they
rig.
use piano wire often? Is that a common product?
I
Piano
haven't heard of that necessarily, but
No?
I could see it being useful.
Okay.
Oh yeah.
This is from Hamilton, and I think I remember having a conversation with someone saying that that's what they discovered to use because it won't tarnish or turn on them.
Sure.
Yeah.
Darren?
Right. Right.
Oh, cool. Nice. So yes, piano wire.
Fantastic.
Would you use the same type of wire for a halo setup, or do you do something different for a halo?
For halo, we usually use elastic. So, and then there's like a switchback. So this is one of our kid microphones. Let's see here.
Okay. So nothing rigid then necessarily.
So nothing really rigid. No. These are great for rehearsals where the performers are in a rehearsal situation. Right. Performers don't want to get in full hair and makeup. Obviously, they just want the microphone in sort of the same place that it's going to be for the show, and then go on stage. Right, in whatever ball cap or hair mane situation they're using. So for a halo, so for rehearsals we'll use halos a lot. This is just elastic between the 2 points, and then we do a clove hitch here, a clove hitch here, and a clove hitch here. And that kind of, when this stretches out, you can see that kind of makes the microphone go straight down the forehead, as opposed to kind of tipping off to the side a little bit.
I like that.
So yeah, that's one of our tricks. Yeah, of course.
Do you ever use redundancy in microphones?
Absolutely.
Yes.
Yeah.
On the leads or
On the leads in particular.
Right.
If somebody can't get off stage, the show that I'm most familiar with is Waitress right now. And the Jenna track is, that lead performer is only off stage for a total of 5 minutes for the entire 2:45 show. Not counting intermission, obviously, because everyone's off stage. But so if something happens with her microphone, we're not going to be able to get to it at all without interrupting the show. So we'll build these double rigs. This is this is Allison's. So one microphone here, another microphone here. I use 2-part epoxy to glue them together so that if you're building one sometimes and you don't have a way to affix the 2 caps together, if you don't get that that first tie point close enough, then you'll hear the 2 capsules clicking together, right? So I just use a little bit of epoxy there to make them stuck. And then it's the fishing wire all the way up. These are Hellerman sleeves, which are like little rubber sleeves that that go on with this tool that looks like some torturous device. So then we'll use that and build it to kind of a single wire all the way down.
When you build a redundant rig like that, will you normally offset the capsules? Will you have them almost even? Will you offset them just for?
It's up to the designer. I mean,
okay.
whatever the designer wants is what I do, right? So some designers want it so that they're right next to each other, so it's fully redundant. Some are fine with setting it back a little bit so you don't see it quite as much, but then you do get a couple of dB of loss or a different EQ shift depending on where it ends up, and then they'll accommodate that in the console.
Yeah, great. And there's a picture of the 2 that are right next.
Right next to each other. Yeah, that's
same
great.
side.
Yep. Yeah, and then going all the way down the back of the head. So we talked about hair a little bit, and then for any performer who has a very short haircut, like mine, if you have a wire that's going down the back of my neck, you're not going to see it. But either of you guys, if you turn around on stage, then you're going to see that wire, right? So we have a multitude of tapes that we use. This is transport tape. I use Tegaderm a lot. Tegaderm is great because it goes on. This is a roll that you can buy, and it goes on literally like transparent. So we use that a lot. And then if a performer is a sweater, there's skin prep and alcohol prep swabs that we can use to go right on their skin, clean off any of the sweat or moisture that might be building up there, and help the tape stick a little bit better.
That's great.
Yeah.
Questions? Any
Yeah.
questions on some of the specific application stuff?
Okay.
Oh, there we go.
I think I got the mic.
Maybe.
I'll stand up so people know who's talking. When you're using the 3M transport tape on somebody a lot, how do you tell them to clean it off so that the next day it'll actually stick again?
It depends on the performer. Some folks don't really need any prompting to clean it off. It also depends on the tape that you're using. The transport tape leaves a lot of residue behind. The Tegaderm tape doesn't leave quite as much. We have, I think I brought some. Yeah. Smith & Nephew, there's a bunch of different companies that it's like all medical product stuff, right? So this is called Unisolve. It's an adhesive remover that's safe for human skin. So they can use that at the end of the day, or an alcohol swab, either, whatever works better for them.
That's the same company that makes the skin prep?
I think so. Yeah,
How
same
often
company.
do you use the skin prep? That seems for me, if I use that, it comes on and off easier.
Sure. Yeah.
Besides the trouble with some ones. Not using this.
Right. To be honest, I haven't used skin prep a lot in the shows that I've been working on because the performers haven't been sweating quite as much. I did Shakespeare in the Park quite a few years ago, and there was one performer who was buckets every single day, and that he used skin prep every day, and it did help with some of the, like, sometimes performers will react if you're putting tape on and off 8 shows a week, right? Their skin will start to react and build up like a red patch. So the skin prep helps with that. There's also another one. This one, there's a barrier one that I think it just like closes their pores a little bit. So it doesn't necessarily, skin prep will leave a sticky residue. This doesn't leave a sticky residue quite as much. So maybe that would help. Does that answer your question at all?
I've found in transport, it deflects too much from the light, so I use a concealer stick. You can't use liquid makeup and it dissolves the 3M.
Right, sure. So you put makeup on top of the tape then?
On top of the tape, just put a little bit on your finger of the concealer stick.
Sure.
And blend it in so that it hides it.
Yeah.
That way it doesn't shine.
Absolutely. That helps too. Yeah.
Thank you.
Yeah.
Using the same stuff to clean off the cables? Clean the same swabs to clean off the cable residue from the cables themselves?
You can. I try not to use alcohol very much because what happens with this cable is it'll become very brittle and dry if you're using the alcohol swabs to clean it off every day. So I honestly just try and do this a little bit, and you can kind of get the adhesive to ball up, and then it'll come off that way.
So our little trick at DPA is to
Yeah.
use olive oil.
Ah.
Put some olive oil on your fingers and slide it down the cable, and the stuff comes off, and it conditions the cable.
And it conditions the cable.
So, yeah.
Brilliant.
And
Oh,
it tastes delicious.
smells nice and fruity. Any other questions? No? Really?
Well, that was easy. We're at the limit anyway. We're at, right?
What's that? This is the Hellerman. This is the Hellerman tool. So these are. This part right here is a Hellerman sleeve. It's like a little rubber sleeve. I don't know if I brought the sleeves themselves. No, I didn't bring the sleeves themselves. It's a little like rubber tube. So we'll use you can use like machine oil, but it stays behind. So often what I'll use is the hand sanitizer. Thank you. And so you put a little dab of hand sanitizer on it, put the Hellerman sleeve on top, and then the sleeve opens up. You can put the microphone through and then slide it off. So that's what that's for. Yeah.